Good day, sir. My name is John Mark Apolonio, and our topic for today's video is all about organic LEDs used for modern smartphone screen. Let's proceed to the table of the contents. First one is introduction, followed by what is OLED. Next one is the structure of the OLED, and then the types of the OLED, and the last one is the advantages and the disadvantages of the OLED. An organic light-emitting diode, also known as OLED, is a light-emitting diode, also known as LED, in which the emissive electroluminescent layer is a film of organic compound that emits light to respond to an electric current. OLEDs are used to create digital displays in devices such as television screen, computer, portable system such as mobile phones, handheld game consoles, and PDAs. A major area of a research is a development of white OLED devices for use in the solid-state lighting application. OLED displays device for organic carbon-based films sandwiched together between the two charged electrons. One is a metallic cathode and the other is the transparent anode, which is the usually glass OLED display can use either passive matrix or active matrix addressing schemes. Active matrix OLEDs require a thin film transistor backplane to which each individual pixel on or off, but allow for higher resolution and the larger display sizes. An OLED display works without a backlight. Thus, it can display a deep black levels and can be thinner and lighter than the liquid crystal display LCDs in low ambient light condition, such as a dark room. An OLED screen can achieve a higher contrast ratio than an LCD regardless of whether the LCD uses cold cathode fluorescent lamps and the anode backlight. Is OLED. OLEDs are organic LEDs, which means that their key building blocks are organic materials. Unlike LEDs, which are small point light sources, OLEDs are made in the sheet that are diffuse area light sources. OLED technology is developing rapidly, and there are a handful of products offering which efficiency, lifetime, and the color quality specs that are comparable to their LED counterparts. However, OLEDs are still the some years away from the widespread use as a source of the general illumination, largely due to the high cost. How does an OLED works? OLEDs works in a similar way to conventional diodes and LEDs, but instead by using layers of the N-type and the P-type semiconductors, they can use organic molecules to produce their electrons and the holes. A simple OLED is made up of six different layers on the top and the bottom. There are layers of the protective glass or plastic. The top layer is called the seal and the bottom layer is the substrate. In between those layers, there's a negative terminal, sometimes called the cathode, and the positive terminal called the anode. Finally, in between the anode and the cathode are the two layers made from the organic molecules called the emissive layer, where the light is produced, which is the next of the cathode, and the conductive layer next to the anode. OLED emits light. Number 1. To make an OLED light up, we simply attach a voltage potential difference across the anode and the cathode. Number 2, as the electricity starts to flow, the cathode receives the electron from the power source of the anode, loses them. Number 3, now we have a situation where the added electrons are making the emissive layer negatively charged, similar to the n-type layer in the junction diode, while the conductive layer is becoming positively charged, similar to p-type material. The last one is positive holes are much more mobile than negative electron, so they jump across the boundary from the conductive layer to the emissive layer. When a hole, a lack of electrons, meet an electron, the two things cancel out and release a briefly burst of energy in the form of particles of light. A proton, in other words, this called recombination. Because because it's happening many times a second, the OLED produces continuous light for as long as the current keeps flowing. OLEDs. An OLED is a solid-state device consisting of a thin carbon-based semiconductor layers that emits light when electricity is applied by adjacent electrodes. In order for light to escape from the devices, at least one of the electrodes must be transparent. The intensity of the light emitted is controlled by the amount of electricity current applied by the electrodes. In the light's color is determined by the type of the emissive material used. To create white light, most device uses red, green, and blue emitters that can be arranged in the several conf configuration as illustrated below. First one showed that 1, 2, or 3 emitters, also known as single stack OLED, the simplest configuration for the low-cost manufacture. The next one is the stack or tandem, also known as stack OLED, a more complex structure that can magnify the brightness without increasing current density. The last one is the color tunable or strip OLED. Requires partnering but allows for color tunability, generally red, green, blue, or the blue-yellow stripe. So let's proceed to the types of the OLED. First one, passive matrix. Second one, active matrix OLED. Third one is the transparent OLED. Fourth one is the top emitting OLED. The fifth one is the flexible OLED. And the lastly, white OLED. Matrix OLEDs. They have a strips of cathode organic layers and stripes of anode. Anode and cathode stripes are placed perpendicular each other. Pixels are generated at the region where cathode and anode are intersected with the emitted light. A current is applied to some strips of cathode and anode to determine pixel whether on or off. Also, this amount of this current affect the brightness, although these types of OLED is easier to produce. compared to others. They consume more power, which is because of the supplied current. However, power consumption is still less than LCDs, and they are suitable for text or icon-based small screen around 2 to 3 inches. For instance, some cell phones and MP3 players have these types of OLEDs. Active Matrix OLED. The active matrix OLED or AMOLEDs, they have a full layers of cathode, organic molecules, and anode. However, this is a thin film transistor or TFT which form a matrix of the anode layer. Top emitting OLED. They have opaque or reflective substrate. They have mostly active matrix design since it fits best. This type is used in the smart card. Transparent OLED. Transparent OLEDs have only transparent components, substrates, cathode, and the anode, and when turned off, are up to 85% of transparent as their substrate. Flexible OLED. Very flexible metallic foils or plastic are used on this substrate of foldable OLEDs. They are very light and strong. They are used in the cell phones, thus productive will be stronger and breakage issues. Other areas that these types can be integrated computer chips in the devices. White OLEDs. White light is emitted in this type and it generates a brighter light. It also more uniform and more energy is efficient than regular fluorescent lights. So let's proceed the advantages and the disadvantages of the OLEDs. So let's proceed to the advantages. First one, OLED are biodegradable. Second one, OLED are thinner, lighter, and more flexible compared to the crystalline layer LCDs or LCDs. Third one, OLEDs are flexible. They can be folded and rolled up as in the case of the rolled up displays embedded in textile. This because of the substrates used in the OLED in plastic rather than the glass used for the LCDs or an LED. The last one is the OLED are brighter than the LCDs. So let's proceed the disadvantages of the OLEDs. First one is the lifespan. Lifetimes of an OLED is lesser than LCD. Red and green OLED films have the longer lifetimes, up to 40,000 to 230,000 hours. Blue OLEDs currently have much shorter lifespan, up to around 14,000 hours only. So you can see the difference between those two. Number two is the material use. In order to produce the blue light degrades faster than with the materials, producing other colors, this causes reduction of overall luminescence. The third one is the interaction of OLED with the water cause instant damage. The lastly is OLED uses three main more power to display an image with white background. Usage of white backgrounds leads to produce battery life of mobile devices.